Hello, guys. Okay, so we're in week 2, and we're going to be doing creating and solving algebraic equations. Your objective for this week will be you will create and solve equations using the distributive property. Now, I don't know if you've heard this before, if you know what distributive property is, so we're just going to go over it. Make sure that for this week, what I'm going to have you guys do is while you're watching this video, I want you to take notes. Whatever notes you end up taking, I want you to write them down, right? Like into your notebook or whatever it is, right? So like write down your notes, right? And then I'm gonna have you take a picture of them and then upload them, and then you're gonna get the points for watching the video and answering the questions for the video. I know it was a little confusing because last week I had you guys go through the lesson portion, and you had like kind of like two PDFs to go through. I'm gonna make it so you only have one PDF to go through, and that's gonna be the homework and practice at the end of this week. However, I am gonna want to see your notes. The reason for this is because I want to see you writing things down. I want to see you asking questions through the notes. I want to see if you've gotten the problems and objectives on there. Okay, so with that in mind, why don't we move on to distributed property? So in your notes, you should have this. You should write this down in case you already don't. The distributive property is it's a tool that you're going to be using in order to solve equations, right? What that means is whenever you have a situation like, let's look at this 3, for example, here. Whenever you have this 3 in front of the parentheses like that, that says a couple things. What we have here is an expression. It's not an equation. An expression is just a set of terms, and it has nothing to equal to. So if you notice here, what I have this expression, I'm going to narrate it. It's going to be 3 times parentheses x plus 20. That means that whatever x is has to add to 20 first, and then at the end, it's going to multiply by 3. Now, with that in mind, what is distributive property? It pretty much, you're going to follow these steps in order to do it. Distributive property lets you multiply the sum of terms inside of the parentheses. Now, I have the definition over here, but pretty much what it is you're going to multiply that 3 by everything inside the parentheses. So if you look, we have our normal expression, 3 times the parentheses x plus 20. Then the next step here, right? This is the next step here. 3 is multiplying by that x. It's also going to multiply by that 20. Now, here's where it gets interesting. When you solve this, when you do a distributive property, if you notice here, 3 times x is just going to be 3x. I just combine them together. My 3 is the coefficient, right? And since we don't know what x is, I can't solve what that is. So I'm going to leave it as 3x. Then the 3 times the 20 over here, 3 times 20 is going to be 60. If you notice here, I have the step says I can't combine. That's because I can't. This has a variable attached to it, right? And this is a regular number. It's just a regular term. I can't add 60 to 3x because 3 is multiplying by x. And since I don't know what x is, I can't multiply it. So I'm just going to leave it like that. I'm going to leave it as an expression. You're not going to leave it alone because there's going to be other steps that you're going to do, and we're going to see that right now in the next example. So if you don't already have this in your notes, please write it down. We're going to move on, right? So let's look at this real world problem, right? Aaron and Alice are bowling. Alice's score is twice the difference of Aaron's score and 5. The sum of their scores is 320. Find each student's bowling scores. Okay, so right away, this is confusing, right? It's confusing for a couple of reasons. There's 2 people, right? We know that this Aaron and Alice are bowling. Alice's score is twice the difference. Now, notice I underline twice, I underline difference right here. Twice is referring to multiplication, right? So I'm going to say that this is referring to multiplication. I'm going to cut it off there. Difference is referring to subtraction, right? Or takeaway, right? And the score of 5. This is confusing because of the way they worded it, but you're going to see this a lot, and you're going to have to figure out what it is that they're talking about. So here, we don't know what Aaron's score is. Here, we know that there's 2 people, but we don't know what Aaron's score is at all. So we have Aaron's score, right? And we have Alice score, right? They each scored points in the game, and we want to know how much each of them scored. We don't know how much Aaron is. If you notice right here, it doesn't say anything about what Aaron scored. So we're going to go ahead and represent Aaron's score by a variable or an A. I'm just going to say A because Aaron is A. We don't know his score. We don't know anything about his score. So that's our variable. We're going to just say that Aaron's score is being represented by our variable A. Alice's score, however, depends on whatever Aaron's score is, right? Alice's score is twice the difference. So we know it's going to be 2, and we're going to multiply that by whatever the difference between Aaron's score and 5. Now, if you notice, in order for us to double Aaron's score and we can't just double Aaron's score and subtract 5. That's not what it's saying. It's saying the difference of Aaron's score and 5. That means that whatever Aaron's score is, remember we represented by A, we're gonna have to subtract 5 from that before we multiply by 2. Why don't we go ahead and show this in another screen, right? Okay, so I've organized it for you a little better here. Alice's score is represented by 2 times A minus 5, the unknown variable. We also have this last piece of information. Alice's score plus Aaron's score is 320. Okay, so we're gonna have to use all these things to figure out what Aaron's score is, and then we're gonna use Aaron's score to figure out what Alice's score is. All right, so why don't we go on to the explanation. So Alan's score is twice the difference, right, of Aaron's score and 5. As we already said, we have to subtract Aaron's score, whatever it is, and again, we don't know, so we're just gonna put an A, minus 5. So Aaron's score minus 5, right, whatever that is, we're gonna double that, which is why we put parentheses. The parentheses, if you notice here, I put them there because that lets me know that I have to do this, I have to subtract first, right? So whatever it is, I'm gonna subtract first, and then I'm gonna multiply it out. All right, so remember, parentheses always, always, always have priority, okay? Which means that we're gonna do whatever's inside the parentheses first if possible. All right, so how do we figure this out? Now, I just put a bunch of things on the screen, so remember, if you're taking notes, go back if you need to go back. Here, if you're already here, go ahead and start taking notes on this while I explain what's going on. Pause the video if you need to. We're gonna use the fact that the sum of Aaron and Alice's score is 320 to write our equation. We know that Aaron, remember, is represented by A, which is why I have A here. We know Alice's score is represented by 2 times A minus 5, according to the problem. And we know that if we were to add both of these, we end up getting 320. So this equation that I have here, it didn't come out of nowhere. I'm using the problem, right, to kind of try to create something, right? So here, what am I going to do now? All right, so what? I have my equation. How do I figure things out? Well, I'm going to have to distribute, right? We have a number, 2, that's outside of the parentheses, so we're going to multiply that. And as is shown here, we're going to multiply the 2 by the A. We're also going to multiply the 2 by the negative 5. Be careful here. One of the most common mistakes I've seen students make is they say they're going to multiply by 5, and then they end up adding here, changing the sign for whatever reason. The sign is, this negative sign belongs to that 5. So when you multiply 2 times 5, it becomes, it's not 2 times 5, it's 2 times negative 5. So you end up with a negative 10. This way of thinking ensures that you get the right operation. But anyways, well, we end up with this. We end up with A plus 2A is minus 10 is equal to 320. Notice after we do the distribution, the parentheses disappear, right? This became this down here. Now, if you also notice, I wrote a 1 here, but I didn't write a 1 here or here. The reason for that is because, as I said in the last video, whenever we have a coefficient of a 1, we usually don't write it, because what that's saying is we're saying that there is 1A here, right? But we can see the A. The only time we need to put a number in front of it is if there's more than 1, because that lets us know that I should be multiplying. Here, 1, whatever A is, times 1 isn't going to change anything. So that's why we usually don't put it. I'm putting it here so you can know where I got this 3 from, right? So in this next step, we're going to combine like terms. All right, so the like terms are everything with variables in it needs to combine. Everything with regular numbers needs to go with the regular numbers. So in this case, I have 1a plus 2a. And since they both have an a attached to it, I'm just allowed to add them. If I have 1a and I have 2a's and I combine them, I have a total of 3a's. Right? Now notice they're both positive, so that's why there's nothing in front of here. Excuse me. Nothing in front of here. There's just 3a minus, and then we have 10, right? Our job here is to make sure that a is by itself. It's not by itself. It has a 3 attached to it, and it has a minus 10 in that same side on the left side of the equation. So we're going to isolate by adding 10. We got to get rid of that 10, right? So here, we're going to add 10 to both sides. Now, if we add 10 to the left side of the equation, right? If you guys remember from the last video, if we add to the left from the left side of the equation, right, we also have to add to the right side of the equation, which is why I have plus 10 on both sides of this equation. When I add 10 to the negative 10, they cancel out. They go away because 10 minus 10 is 0, right? And then when I have here 320 plus 10, I added them together and I get 330. That 3a that I came up with, it just comes down. The next step, right, I have 3a is equal to 330. Okay, so here we're almost done. So I'm going to divide both sides by 3. The reason is because 3 is multiplying by the a, so I have to do the opposite. And the opposite of multiplication is, well, division. That's why I put the little division line. The 3 cancels out, and I'm left with a is equal to whatever 330 is. So go ahead and put out your calculator or whatever. Go ahead and divide 330. Make sure to put 330 first, then divide by 3 and see what you get. Pause the video right now, write down what you get, and then unpause it because we're going to find out. So a, or remember, we were solving for Aaron's score. Aaron's score is a. When we end up dividing 330 divided by 3, we end up getting 110. That means that Aaron's score is 110. We figured out what Aaron's score is, but we're not done. We need to figure out what Alice's score is, right? So Alice's score, remember, it was represented by 2. It was twice the difference of Aaron's score. Well, now we know what Aaron's score is, right? We know that A is equal to 110. So we're going to use that, and we're going to plug that in, right? So here we have 2, right? And times the difference of 110 minus 5. So 110 minus 5, right, is going to end up being 105. And we have 2 times 105. That gives me Alice's score, right? Alice's score is 210 at this point. Okay, so how do I know if I'm right? Well, let's go ahead and check our work. So we know that because of the third equation, I don't know if you guys remember all the way back, go ahead and pause the video if you don't remember, but the third piece of information from the problem said that Aaron's score plus Alice's score has to equal 320. Well, we figured out that Aaron's score is 110. We just found out from the previous one, if we go back here, right? We just found out that Alice's score is 210. If we add them together, we should get 320. And if we add them together on the calculator, we get 320. Okay, we're done. We did the problem correct. Good job. Unfortunately, we're not done with the video. So we're going to move on to the next problem. This one's important because you are going to be seeing this in some of the harder problems. Okay, so create and solve equations with variables on both sides. So what do I do if I have the same variable on both sides of the equation? What do I do? Here's what we're going to do. We're going to look at a problem, right? I'm going to read off what the problem says, and then we're going to break down the problem what we have here. So make sure to pay attention at this point. Jane has a job offer at 2 companies, right? One company offers a salary of $28,000 with a raise of $3,000 per year. The other company offers a starting salary of $36,000 plus $2,000 raised per year. In how many years will her salary be the same with both companies? What will her salary be? Okay, so instead of showing you the problem, I've organized it for you here because again, this is an example and I want you to understand how I got that information, this information from that information. Okay, so the problem is broken down like this. Jane is offered a job at two rival companies, right? I'm going to call them Company A and Company B. The problem didn't calm down. I'm organizing it that way so I know what it is and I can shortcut this later. I know Company's A's offer is they're going to pay her $28,000 a year, and every year they're going to give her an additional $3,000 per year. Now, this word here, by the way, it's a clue. It means multiplication, right? Because that means that if she's working there for 1 year, she's gonna get $3,000 raise at the end of that year. If she's working for 2 years, she gets another $3,000 on top of what she's making. So every year you add $3,000 on top of that. In order to make an equation out of this, we're gonna have to make a variable with that. We're gonna get into that later. Anyways, let's look at Company B stats. Company B, $36,000 per year plus a $2,000 raise every single year. Okay, cool. So the problem says, in how many years will her salary be the same with both companies, right? What will her salary be? Let's see. Due to the raises, even though Company A is going to offer her less money in the beginning, after a certain amount of years, she's going to make the same amount of money for Company A as she's making for Company B. We want to know how many years that's going to take, right? That's what the problem is asking. Let's get to it. Oh, Company A's salary plus 3,000 a year is going to equal Company B's salary plus, and I don't know if you can see it here, but it says $2,000 per year. Did I write that backwards? I might have written that backwards. Sorry about that. So here, why don't we go ahead and put into an equation, right? We're going to have to write our equation. We have $28,000 a year, which is Company A's salary, plus the $3,000 a year raise. And if you notice, I'm gonna make y the same as years, which is why I have 3,000 y, because 3,000 is gonna multiply by y, right? If she's only working for 3 years, right? 3 times 3,000 plus her salary is gonna be her full salary, right? So 28,000 plus, right? 3,000 y is equal to 36,000 plus 2,000 y. That's our equation. We need to get all the variables on one side of the equation. I either have to make them all on the left side or on the right side. It honestly, it matters in the sense that if you want it to be less work on you, always try to make sure that when you're moving the y over, that you don't end up with a negative. Because here, what I'm gonna do is I want the y on one side, so I'm gonna subtract 2,000 from this side because this side has a bigger y. If I subtract 2,000 from this side and this side, I end up getting a positive 1,000. But if I did it the reverse way, if I tried to subtract 3,000, I end up with a negative number. And I don't really want negative numbers. You can still solve it. It's just extra steps for you. Why don't we try it this way for now, and then we'll deal with the negative numbers later. So, right, I'm going to remove the y, right? I'm going to subtract 2,000 y from this side. So the y's are gone from the right side. Remember, this is the right side of the equation, and this is going to be the left side. Whenever I say those words, that's what I mean, right? So minus 2,000, right? Y minus 2,000, I'm left with 28,000. I'm right here. Plus 1,000 y, because I subtracted, is equal to 36,000, and there's nothing here. Now I want all the regular numbers on the right side of the equation, right? So I'm going to subtract 28,000 from both sides. If you're wondering why am I subtracting, well, 28,000 is technically a positive number. All these numbers are positive numbers unless there's a negative in front of it. If it has nothing in front of it, it's adding, right? If it has a negative in front of it, then it's subtracting. Then you would have to do the opposite. You'd have to add. But for now, since they're all positive, we're just subtracting. So here we end up canceling this out. I'm left with 1,000 y on the left side of the equation, right? And is equal to 8,000 because when I subtract 28,000 from 36,000, I end up getting 8,000. So then I'm left with 1,000 y is equal to 8,000. I end up dividing by 1,000, dividing both sides by 1,000. Y is equal to 8 or 8 years. So what does this mean, right? I have my y is equal to 8. So what? Well, it matters a lot if you're the person trying to figure out what company is better, because in how many years will the salaries be the same? Well, Company A, we know that Company A is going to give her $28,000. and every year they're going to give her $3,000 raise. And if Y is equal to 8, if she commits to working 8 years for this company, 8 times 3,000 is 24,000, plus the original 28,000. She will have made $52,000 at company A. And we know that it's going to be the same for company B. After 8 years of working and getting $2,000 every year on top of her salary, she's also going to make $52,000 at company B, right? So in 8 years, she would have made $52,000 a year with either company. So this is where the real world kind of critical thinking comes in. What would be better? What would be better for her to work for company A or company B? Well, if all we know is their salary, is we know that she might make less money for working for company A for the first 8 years. She will make less money until she gets to year 8. Then at year 8, she's going to make the same amount of money as she would working for company B. And then after any year after that, she's going to make more money at company A. So if this was you and you were making, a decision, and you're like, I plan to work for this company for at least 20 years, which company would pay me more money at the end? Well, assuming nothing changes, and this is all true, company A would work out much better for you in the long run. But if you're like, I'm only going to work at one of these companies for 2 years, right? Which one would be better? Well, company B would be better because you'd be making more per year. Only if you're trying to work for them for less than 8 years. Well, that's it for now. I'm going to go ahead and stop this video. If you have any questions, please send me a comment on the Google Classroom. Send me an email. Join my Zoom. My Zoom meeting, right, is from 10 to 11 a.m. Monday through Thursday. Okay. If you have any questions, meet me there. If you cannot make this time, please contact me through email, through Google Classroom, through any way that you can, and set up an appointment with me. I will set up another Zoom that works a little bit better for you and help you out personally with these problems. But if you don't say anything, I can't help you. So once again, good luck, guys. Upload your notes. That way you get credit for this, and then do the problems for the week. They'll be posted on Google Classroom by Monday, 8 a.m. Good luck, guys. Let me know.